In this video, we'll be discussing the various line coding techniques. Firstly, we need to understand what do you mean by line coding. Line coding is nothing but the conversion of digital data to digital signals. Why do we need to do this? Because transmission media will not be able to pass bits. What does your digital data basically mean? Your digital data simply means any groups of zeros and ones. Now the problem is, you take any transmission media, whether wired or wireless, that transmission media will not be able to pass your bit pattern. So what you need to do is, you need to take this bit pattern and you need to convert it into some signal. Now this signal can be then passed to the transmission medium so that it can reach the receiver successfully. So this is what line coding does. It takes your digital data and it converts it to your digital signal. Now there are various line coding techniques available. Three of the broad classes are unipolar, polar and bipolar. Now what is the unipolar line coding technique? In unipolar line coding technique, what you have is your voltages will lie on one side of the time axis, either above the time axis or below the time axis. That means, let's say this is your time axis, and unipolar tells you that all your voltages will lie either here on the upper half of the time axis or here in the lower half of the time axis. And the example that we'll be dealing with is unipolar NRZ. Next comes polar line coding technique. In polar line coding technique, what happens is the voltages will lie on both sides of the time axis. That means if you have, let's say this is your time axis again. Now voltages will lie above the time axis as well as below the time axis. What happened in unipolar technique was, it will lie either here or here. Either here or here. But here in polar line coding technique, it will lie here as well as here. Okay? And under polar line coding techniques, we'll be seeing a number of examples like polar NRZ, polar RZ, and we'll also be seeing two biphase techniques, one being Manchester and the other being differential Manchester. The third line coding technique that we'll be dealing with is bipolar line coding technique, which will use all three levels. Now your question will be, so far in the previous two cases, I showed you two levels, one above the time axis and another below the time axis. But what about the third level? See, if you observe carefully, there are actually three levels at work here. One is this above the time axis, another is this below the time axis, and another is along the time axis. Along the time axis also you can have the signal being transmitted. So that is your third level. Now bipolar techniques will use all the three levels. It will use the upper level, the lower level, as well as the level along the time axis. And under bipolar technique, we'll be seeing AMI and pseudo-ternary. AMI here, now you can see the full forms here. NRZ stands for non-return to zero. That means your signal will not come back to zero. Now in RZ is, you can say in one way it is the opposite of NRZ. Your signal will at some point or the other come back to zero. And AMI is alternate mark inversion. Please note that here mark refers to the bit 1. It refers to your bit 1. It refers to the bit 1. Not bit 0, but bit 1. So what will happen is, your bit 1 will alternate between the two voltage levels. Okay, so what we'll do is, in the next few videos, we'll see an example of each of these techniques. So we'll see unipolar NRZ, polar RZ, AMI. We'll take any bit pattern and we'll convert it into we'll use any of these techniques and convert it into the equivalent signal pattern. Okay, so there'll be a few rules that we need to keep in mind. We'll use those rules and convert the digital data into digital signals. So I hope this helps. Thank you.